Hello everyone. So we already have started some of the experimental demonstration and we have seen how different devices behave, how the experimental process is, and how we can connect a device to characterize it electrically or electronically, whatever it is. And as I have mentioned, the purpose of similar exercise is to give you an experimental exposure so that you know how we can actually characterize different semiconductor devices or semiconductor sensors, and this probably will give you practical knowledge on how we can conduct different experiments. But one thing that you should remember is that the instruments that I am showing is research grade instruments usually, and the instruments that you have seen in your undergraduate lab or postgraduate lab, mostly they are laboratory experiment, mostly they are for normal laboratory experiments. For example, the IV characteristics that we generally record using a source meter can also be recorded with a power source and an ammeter, as I mentioned before. However, this particular experimental exposure shows that if you have a source meter, that characterization becomes much easier because you have a software interface, you can change the voltage, you can record the current using the same instrument. So, instrumentation wise, the thing, all these arrangement becomes little simpler. At the same time, you can also save or export the data for analysis at a later stage. However, if you take a simple power source and an ammeter meaning a multimeter, you also probably have used handheld multimeters. So, you can use an handheld multimeter and then power source, a voltage source, where you can vary the voltage. If the voltage source allows you to vary the voltage in millivolts, hundreds of millivolts, then it's much better. The resolution that you will get is much better, and you can record the current. You take a sheet, write down the current value corresponding to each voltage, and then you can plot it in a graph paper or in Origin or in Excel, whatever it is. That is also possible, and that also will give you similar results. However, this experimental exposure is to give you the exposure of various high-end equipment, which are usually used in different research experiments. So, today we will discuss another diode. We already have seen the characteristics of PN junction, how a PN junction diode behaves. We also have another diode which is very popular, and you must have used it in your undergrad lab, or you must have used it in some small projects, which is known as light emitting diode. So, in this particular course, we haven't discussed light emitting diode in details. The concept of PN junction diode has already been discussed. However, light emitting diode also is a diode. It also has two terminals, P terminal and N terminal. The structure of the light emitting diode probably is not exactly same as a PN junction diode. In many cases, they are very similar, and even if you see the diode visually, the component commercial PN junction diode and commercial LED light emitting diode, visually also they are different. The packaging is different, the electrode arrangements are different, but a detailed analysis of light emitting diode is not a part of this course, and hence I will not discuss the complete theory associated with light emitting diode, which is an optoelectronic device. Maybe in future, in one of the courses, if I offer a course on optoelectronic devices, there I will discuss how that light emitting diode actually works. And there are a lot of research like organic light emitting diode, There are even in inorganic light emitting diode also there are different types of research that are going on. But why I am showing this particular experiment today is to show you that the diode characteristics remains the same. So, usually we use this light emitting diode in forward bias, and you can see that just like a normal PN junction diode, the trend is similar. The one that you have seen in PN junction diode, similar trend you will see here. But in this case, you will also see that beyond a certain voltage, which is above the threshold voltage, and beyond a certain current value, the light emitting diode will glow. So, it starts glowing beyond a certain voltage value, or you can say beyond a certain current value. Now, as the current through that diode increases, the intensity of the light also will increase. Now, in this case, when we do this experiment with a source meter, please focus on the light emitting diode and the characteristics. I will run it multiple times for this purpose, and you can see that initially the light emitting diode glows very fadely, and then slowly as the current increases, it starts glowing brighter because the current is increasing, and then it turns off. The reason behind the switching of this diode is after the characterization is done, the source meter stops providing voltage, meaning the source meter stops working. Once you get the characteristics, the source meter is stopped. So, let us go back to the lab and see how a light emitting diode looks. It has a longer leg, a smaller leg, meaning the terminal, it is a 2-terminal device. And then how we connect the light emitting diode with a source meter, and what is the typical characteristics that we get for a light emitting diode. So, one can think about this and can come up with new ideas also at a later stage. So, let us go to the lab and do this experiment. So, here we will do an experiment with an LED, which is basically a diode because it is light emitting diode. So, you should get an characteristics which is similar to a diode. But before we do the experiment, let us understand how we can connect the LED so that we can get a proper characteristics. So, if you look at this LED, it has 2 terminals, just like an PN junction diode, it also has 2 terminals. And if you look at the length of these terminals, one is little bigger than the other one. So, the long terminal is basically positive, the short terminal is negative. If you want to use this LED for certain purpose, you have to make sure that you connect the LED in a correct way, meaning the long terminal should be connected to positive terminal, the short terminal should be connected to negative terminal, so that the LED remains in forward bias. We have the characteristics of the LED in this screen. So, you can see the characteristics is similar to PN junction diode. The trend, if you look at in the screen, then you will find the trend is similar to an PN junction diode. After certain cutoff, the current actually rises. If the current through this LED is not sufficient, the LED will not glow. So, to do this experiment, what we have done is we have again taken the help of this source meter, where the source meter has 2 terminals, one is red, another one is black. The red one is positive terminal, the black one is the negative terminal. Here we have connected the LED, the positive terminal is connected with the red terminal, positive terminal of the LED, which is the long terminal, is connected to the red terminal. The short terminal of the LED, which is basically the negative terminal, is connected to the negative terminal of the, that is black terminal of the source meter. And if you go to the settings, you can see that we again have considered a voltage sweep, which is linear type, from 1.5 volt to 2.7 volt. The reason we have started from 1.5 volt is we just want to see the characteristics if it is coming properly or not. We can start from 0 also. We will see by putting the start value as 0 volt and how this characteristics works. But when we run this experiment, please look at the LED. You will see that initially the LED is off. After a certain voltage value, the LED will start glowing. And then if you look at the characteristics, you will see that when the current is rising and reach to a certain value, then only the LED will start working. So let us go to the graph and run this experiment, and we will see that the initial value of current that you will get is very small. For example, here it is picoampere, and then the value that you are getting, you will get some spurious value because the number here is very small. So if you wait for some time, slowly you will see that the diode characteristics is evolving. So at this particular value, look at this now, look at the curve. Now the LED is glowing. You can see for a very short duration this LED is glowing, and that is when this current is beyond certain value in this region. So what I will do is, just to show this experiment again, I am again running this experiment. Please check this LED when it glows, and also check the characteristics in your screen. When it reaches to a certain value, then only the LED glows. After it reaches the maximum value, it stops because the power gets cut from the source meter, because the experiment is done, so you don't get any power. That's why finally you see that the LED is turned off. So the characteristics you see here, it's similar to the one that we received before, but let us run it again. As I've mentioned, that initial current should be very low because all diodes have a specific value, threshold value, beyond which the current rises, and initial values will be very small, and then finally you will get this characteristics. Now please look at this. The values that you see here is not the correct one, because you get some outliers. Now you look at the LED, it's slowly glowing. It glows to a value and then it actually turns off because the power is not available. We will do that experiment from 0 volt, and let's see the graph now. So we now have started this experiment from 0 volt, and let's see how this graph comes out to be. And you also can check the LED closely, that after certain value you will see that the LED is glowing. So currently the current that you are getting is very small in picoampere range. As the voltage increases, the current also will increase beyond a certain voltage, but before that the current value is very small in picoampere range. So at even 1.4, 1.5 volt also the current value is in picoampere range. Now you can see the current is slowly increasing, and you look at the LED closely. So now it is glowing, and it glows beyond certain point and then it turns off. So this is an experiment which I wanted to show, that LED basically is a light emitting diode. So you get the nature of a diode in the characteristics which we got, and we also have seen beyond certain value only, certain current value or voltage value, whatever you say, because they are related, you will get the LED is glowing. So LED has different rating. Based on the rating, the value of the voltage and current will vary. For this particular LED, the value you have seen in this characteristics is something which is very specific to this LED. But if you get an LED which has a different rating, probably this value will vary, the voltage and current beyond which the LED glows. And one more thing probably you have observed, as the current increasing, the intensity of the LED is also increasing. So beyond certain current or certain voltage, you will get the highest intensity. So we just have seen the characterization of light emitting diode. We have taken a light emitting diode and we have seen that it has two different types of terminals. one is little longer than the other. The long terminal is the P terminal and the shorter one is the N terminal, and you connect the P terminal with the P terminal of the source meter, which is red in color, and the shorter terminal to the negative terminal of the source meter, which is black in color. In fact, when you connect these probes, the wire that you see are detachable. So, you can actually take those probes out of the source meter and you can insert them back. So, when you are probing this, when you are inserting the probe in the source meter, you always have to see the color code. In the source meter, you will have a red kind of port where you should insert the red terminal, meaning the red wire of the source meter, and there is a black colored probe or black colored port, I would say, and then you can insert the black wire into that terminal. So, these are usually banana clips. So, you can just insert them and it is a plug and play device, and after that you connect the LED in a correct way. If you connect the LED in reverse bias, the LED will not glow. So, this is a very important thing to know, and possibly you already know, but if you have seen the characteristics, which is very similar to an PN junction diode. So, it has a diode characteristics and that is why it is a diode, but this diode emits light. That is why we call it light emitting diode. And we have also seen that how when you increase the voltage, the intensity of the light increases, because if the current is higher, if you apply higher voltage, the current also will rise. So, the current through the device is higher, if the voltage across the device is higher, you will have more generation recombination kind of phenomena inside. You will have more semiconductor physics phenomena happening inside the LED. So, I am not going deep into the semiconductor physics part of an LED because it is an optoelectronic device, and as I have said, at present it is not a part of this course. So, I am not going deep into that subject, but as you increase the current or as you increase the voltage across the LED, whatever phenomena is happening, that will happen in a larger scale, and that is why the intensity increases. However, beyond certain voltage it saturates, it will not, it is not like that. If you keep on increasing the voltage, the light will, the intensity of the light will keep on increasing, because there is a limit, it will saturate, but initially it will slowly increase. So, with this, let us conclude this experimental session. We will learn more about semiconductor physics in the coming lectures. We will learn more about semiconductor devices and sensors in the coming lecture, and we will see similar type of experimental demonstration in future. Till then, thank you.